Okay, let's say you have some lead nitrate in your drinking water, and you want to identify what is the concentration of the lead ions in the drinking water. Well, one way you could do this is through gravimetric analysis, okay? Here I have an aqueous solution of lead nitrate. So I will add a counter ion that forms a precipitate with lead, okay? Now, we could make a phosphate, which is a very heavy compound, and if I added sodium phosphate, which is an aqueous compound, what would happen is that when I added the Na plus and the PO4 minus 3, these two would form an insoluble precipitate. So this is a double displacement reaction. This partner goes with this, so I have Pb plus 2 NO3 minus. I have Na plus, and I have PO4 minus 3. So this forms a salt, which would be of the formula Pb3 PO4 2. And from our solubility rules, this is a solid. This also forms a salt, NaNO3, and this is aqueous. So what happens is after I add my sodium phosphate, and I'm going to add excess sodium phosphate, the lead and the phosphate leave the solution and they form a crystal at the bottom. They fall to the bottom. I could then run this through a filter paper and dry it off and measure the mass of the lead phosphate. I should say lead 2 phosphate. And if I came up with them, and now if I took a liter of water and extracted a liter, so I have 1 liter of this solution. Then I added the Na3PO4 to this liter of solution, and I had excess of the phosphate. This would cause all the lead to precipitate out, and let's say that I came up with 14.06 grams of this solid at the bottom. Now I could ask myself, what is the lead ion concentration that was in the original solution? So if I have 14.06 grams of Pb3 PO4 2, and I divide by the molar mass, that tells me the moles of Pb3 PO4 2. And this has a molar mass of 811.543 grams per mole of Pb3 PO4 2. This is very heavy. It has 3 leads. Each of those weighs around 207 grams per mole. And now I know that every mole of Pb3PO4 has 3 moles of lead. So there are 3 moles of Pb plus 2 per mole of Pb3PO4 2. Okay, and I know that because Pb3PO4 2 breaks up to 3 Pb plus 2 plus 2 PO4 minus 3. Now, if I had taken 1 liter of the solution and 14.06 grams of the lead phosphate fell out of the solution, then this would be the concentration per liter. So I take 14.06, divide by 811.543, and divide by, multiply by 3, and I get 0.0519 molar solution.